language you might have heard before, we're saying we don't have a y-intercept. Or sorry, we don't have an x-intercept. We're not crossing the x-axis. But also so you said we're not going to cross the y-axis either. Why not?
Because if there's 0 workers, those birds will never get done.
Okay, so what kind of shape then, like what's going to be happening here if we're not actually going to cross these axes?
X going to be
It's
like,
going to be a tripod.
So maybe it's going to be some kind of curve, more curved shape. All right, so maybe this one isn't the best. Maybe we're saying, so you guys are thinking something more like this? Okay. And do you remember what it's called when you've got some shape, some graph, and it's like maybe it's approaching an axis? Okay, so a parabola is definitely a curved shape that's not gonna, like, it's gonna kind of shoot off to some sides. But I think we kind of agree that it's gonna like maybe get close to this axis. Like it's gonna get less and less time. Or if we have, fewer workers, what would it be called if we're like approaching a line but not crossing it?
an asymptote.
An asymptote. Okay, so maybe we think kind of there's like an asymptote going on. Does anybody else have other ideas or thoughts about how you got started on this? Or different ideas you want to share? So I have a question for you guys. What I've drawn here is what we would say is a continuous graph, right? Does this sound familiar? So kind of like the loosey-goosey definition is just like there's no breaks in it. We know there's a fancier definition that has to do with limits. But should this really be a continuous function?
No.
Why not? Why not?
You can't have half a worker.
Because you can't have half a worker. So this is one of these settings where I completely agree with you guys. This is a good general shape. But maybe we don't really have, all the values. We only have whole number values, right? Like we could have one worker, I guess we could have 0 workers. We could have 1 worker or 2 workers or 3 workers. And so what we're saying is really what I'm drawing here, these like purple dots, these might actually be, so the purple dots might be kind of the best function for this problem. Can I draw a dot in for 0? Like at x equals 0? Can I draw a dot?
No.
That would just be
No, it would just, this one would be kind of like undefined, right? How much time would it take if I had 0 people working on it? We might say it would take like infinity time, but infinity is not a number. This is a hugely important theme in Calc 2. Infinity is not a number. We'll come back to infinity. But so what this means is that sometimes when we're working with functions, I know like our natural inclination is usually to work with continuous functions. But in the real world, a lot of times the functions that we're going to need to model things are not continuous. What if you want like a fancy word for this sort of function that's just a bunch of individual dots? You might actually call it a discrete function. Any questions or additional thoughts? So, great. That was good fun. But I also want to give you guys a chance to do more of these on your own. So what I have for you all, maybe we'll just work with one. If you guys want to push desks together, that would be great. Get with a partner. I don't know how we're partnering up, but if you guys want to like push your desks together for partners, we're going to do this for a little while. What's going to happen when you pull these things out is that you've got kind of on the blue sheet is a scenario, kind of like the bridge painting problem. And then the orange sheets or the coral colored papers are pictures of graphs. So you can ignore the purple ones for a second and just think about the blue scenario and which pink graph you might match it with. And if you think that you would modify the graph, you could think about that too, like whether you think these work out. But there should be matching that works out. Okay. So get into your partners and start figuring out how to match these. And I can forget all the stuff that I said. All the Oh, sure, yeah, I know, now we're an odd number, so please, by all means, be a team of 3. I know, ooh. Okay. But everybody else knows. Here, if you guys want to be a team of 3, but you want to wait. Here, maybe a team of 5. Do it however. We'll deal with those in a second, but right now we're just doing the thing we did before where it's not going to have, exact values. It's just a general shape that you feel best models the situation. And you can kind of start with, I think there are a variety of, like, some of them seem easier than others, so it doesn't have to go in order. Oh, and you guys don't need to worry about the purple ones just yet. So really for right now, like, yeah, we'll do those ones after, but right now it's just this very kind of general matching situation of what shape do you think best models the situation. like you can explain where this came from. So,
Maybe you want me to just go over all?
no, not necessarily, we're gonna share things, but maybe, so I don't know, were there any that you were like, oh, this one is tougher, or that you just arrived at because of how you matched other ones?
Sounds like a little longer than
Oh, dude, this one's.
besides that.
Well, so, okay, so here I have. This guy. So.
I was like, hold on, like,
I know there's two golf ones. So I think this seems good, right? You're like, you were thinking the height limit starts out low and then it goes up and then of course the ball falls back down. This one now is like about how fast the ball is moving.
Or maybe it could be, because.
I know it's hard if you don't have space to like see
Let me go out.
graphs. Yeah, but maybe, yeah, I would rethink that one, which means, I guess there's a second one to remake. And you can also, debug these dudes too, to see what they're getting for something.
You guys can say it once.
Okay, nice. The first one, what else would you stand?
Yeah, no, it's okay, it's mine.
I'm like, I understand the outline, but right now it's just like,
Definitely, and that's okay. This is what we're kind of, this is supposed to be like a warm-up week where we're like, what have we even been doing with our lives? Yeah.
it's a circle, so you just go, it's like sign
Any questions or
Yes,
just
she
kind
says,
of
right.
making some progress? So when I see you guys are making a lot of progress and towards the end, I will ask people to share. So if there are some that you're like, yeah, I feel like I can really explain that, volunteer.
You said you what?
G6 or. So you want
You're right, that concern, the one that stops increasing dramatically. Let me see.
What about for just G?
The G.
Yeah.
That's for sure G1. G is G1.
Do we have any questions or think, like, I don't know, ones you'd like to talk about with me?
For G folding paper is G1. Because when you fold the paper, it starts decreasing rapidly. When you fold the paper,
Oh, so I think the questions that are kind of like sample questions you might ask that you would solve by using the function you create. So I'm sorry, those are just kind of samples. So kind of what it's saying is like the only information we have is that like you walk into this internet cafe and they say, it costs you 25 cents a minute or 50 cents a minute, and so what should happen over time? And you might, I think something that we did when we were doing the pre-training was like, well, if there were 0 workers, we know something. If there were lots and lots, we know something. Like here, what would you say if you had spent 0 minutes? How much? Yeah, it would be low. And in fact, at 0 minutes, it would be 0. Ah, okay. And then you start going up. So now, which of these? Which one is a picture? That starts at
Click at
got
first.
some over here too.
But then, as it's in the air, it will slow down. No one's going down and go fast again. Keep it
I know what you're
high.
saying. I'm like, right?
For sure.
It would be G5.
Different process.
how'd that go?
So kind of.
Yeah, okay, so I'm gonna tell you right now too, I thought that H was the trickiest one in this, in this whole thing. So it's kind of, yeah, it might be kind of a process of elimination, and then we can kind of explain why we think it's that one. But, yeah, I don't, like, there are some of these that maybe you could start saying, I'm pretty sure that's correct, and it's something you're thinking about. If any of the ones that you feel like maybe you were especially iffy about.
I don't think it's gonna start to change. I'm gonna slow down and get faster.
Cause of gravity. That's what I'm thinking.
Right, you guys get angry.
Yeah, you guys are talking, yeah, I think you guys are talking about the one that you're
No,
thinking
but it's
about.
tight in the ground.
So maybe you can share your
What
idea.
you prefer?
So like,
Or what
at this point,
Right now, I'm still stuck on it, I'm trying to figure out which.
I wanna go with G, because it would be fast at first, but then as it goes here, it slows down. And when it goes down, it starts fast again.
Yeah, I think these are definitely.
Doesn't it,
You see that? It's like,
So
And
what
then
things you
zero,
have
one
at your
zero.
disposal? And this is
One
maybe
is
hard to
right.
tell, but I guess this
But
one is
the
saying
process while it's
really
here is still moving on the
active
speed.
and just leave it.
let's look at our
So
options.
of these,
Yeah,
which one does it
it's-
really
right
seem
now,
like
No, no, it's-
has
it's-
to
Yeah,
no,
right now,
zero
it's
or
like-
at distance zero? So is the thickness of your paper actually 0
I feel like
inches?
it needs to be more, because that's.
No, it's very tiny, like the paper's very thin, so it's very close to 0. So which one is actually just like
Because it
closest to
starts off
0?
with a T.
So yeah, so this one, if it was 0 feet, you wouldn't be able to see it at all. Yeah, okay, I agree. I think that's a good one. So now you can. Does that seem, yeah, so I agree, it like starts at a good spot, and should it increase kind of?
I feel like
when you fold it in
it might
half,
be
what
G9
happens to the
grade.
thickness? It
Well,
grows, by how much?
G9?
By double. So what you're doing in that problem is you're
When it goes up
you're
to
doubling
the-
stuff. So what shape,
Yeah.
or what kind of function is it?
Would be for L.
So that's a good, so I know this looks kind of like half of a parabola, but it's maybe going like even steeper. I think, like 2 times 2 times 2 times 2 over. Would give some kind of exponential. Right, like I don't know, did you guys have this project or modeling problems? And then they like double and grow exponentially, right? Because they like double and double and double, and that's maybe.
Oh, yeah.
I had to do the same thing project, and I was like, it's the same, and like, that's a, I think,
Here, we should go from A. So for A,
How are you doing
I
now?
got. So you took the what
Yeah, this is very easy to do, right?
For
So
B,
which ones are you like making a notes to?
Same.
C, I got G.
Okay, so, yeah, so we're like,
So for A, G2, for B, G10.
so, so let's pick one.
G4, D.
Okay, so what's happening with that one?
Yeah.
For E, I'm just doing G1 and G9. That one.
I feel like it's still.
Good, okay, so I agree, like the general shape, you're like, it's definitely an increasing
Because it's
curve.
not,
And
it's
now
not,
let's maybe think
one
about like
wire and a one.
extreme points.
Yeah.
Kind of like different
It has to
things,
look
right?
aligned.
When there were 0 workers, it would maybe take infinitely long. So here, it says just charges even for showing up to your house at all. So let's say he like showed up and he was like, oh, you just do this, and then he walks away.
G,
So he took like roughly 0, like 2 minutes or something.
when it goes
Should
to
it be
H,
actually at 0?
that's right about one.
Is he actually charging $0 for showing up?
For which one?
No, okay, he's not. So maybe what you want
After H.
is a
I
slight
think it's G1
difference
because,
Right?
going in
Yeah.
I
fast.
like it, maybe.
Yeah, maybe
Because if
you
you have
need
an
one
average
that's
speed of
getting
0,
up that
whatever,
like
you
actually
keep track of it.
starts at
you can't finish the track instantly, no matter how fast you are.
and then increases.
Do one for that one. For the balloon, I got you. And
Okay, yeah, so then what it
Yeah.
would
then for K.
So this one you get 2 copies for free, so what does that mean at? That looks good, yeah, because you're saying like, you don't pay anything for showing up for 2 movies.
You never know.
Okay. That's good, now maybe you can, I don't know, if you you want to treat, I think for a lot of things, it's very useful to think about, like, what's the stupidest case? Like the case where I spent 0 minutes in that internet cafe, where the film projector is like right up against the screen. What happens for that stuff I know? So do you got that?
We figured it out.
Yeah, okay.
I'm gonna set up mine, but
Okay.
we have this.
Okay. So, what is right at, okay, so.
Are we including like, I doubt it,
Yeah.
but it's like from here, are we still confident unless we do it with all that?
Yeah, so the Y is asking the height of the seat from the ground. So like if you've gone up a little
Then
bit.
here they'll be okay.
That's right. So you'll have 2 different points where it's actually the exact same height from the ground.
Yeah.
So what kind of graph has maybe multiple places where you're even the same?
So that's why it would be a start.
Oh, good, okay, because you're like, this will be the same as this, or this because you've got multiple of these. So now the Ferris wheel, maybe it goes around multiple times, right? I mean,
It's not like
it's not like a one revolution. Yeah, that's a good question. So maybe this is slightly ambiguous, and you're saying like, well, if it just goes around one time, then I think it's probably like that. But I'm gonna tell you that with this Ferris wheel, it's like,
never ending.
it just keeps going. It just keeps going. So then, okay, so now you guys, yeah.
But I wasn't, that was like, if it only goes once.
That's right, that's a really good point. I'm gonna ask you to share that.
Remember I asked you, like.
Alright, so are we at like a satisfying conclusion? Are there any that you are like, if I asked you to explain it, you'd be like, I'm not totally confident. All of them? No, not all of them. How about, okay, like the Ferris wheel one. Was there? Yes, there was. Maybe you should look at it.
And then
Take a look. So, did you guys feel like you could explain? Okay, because I'm gonna call on people to explain ones and you can volunteer to. So if you guys want to just like.
Oh, I have a question.
Yeah.
I got here late, so I go some.
That
I
is a
think
nice
you
question.
talked to Naomi, she was like right there. Yeah, she took my attendance right before she came.
Yeah, she might be roaming the halls and you can find her. The attendant sheet will be coming back for the afternoon. And I can assign you her.
I never phoned her. Yeah. Getting her B plus the test at the end. I said like the extra hour.
So we're gonna reconvene in just a couple more minutes, and if you didn't finish, that's okay. But maybe take just another 3 or 4 minutes to kind of get a couple more that you think you could explain.
Are you thinking of this, Sal? Just telling you now, sit in the front of the class, don't sit in the back. He's a little hard to understand. So yeah, you want to sit in the front, and plus, if you want to stay involved, you're going.
I don't think there's anything right, you totally can, but if you wanted, no, actually, you can. Well, if you wanted to start thinking about this, you totally can. But something that you could think was, were there any of these that you matched, that you thought, well, that's gotta be what it is, but you didn't think it was the best answer?
We had a few of those, but then we
Oh, okay. Because like the example that I'm thinking about, and you guys have maybe, some people have slightly different ones.
that was the one that we had a little trouble.
Yeah.
We had like,
Oh, about like, should it
this
be,
one or the-
that's a good, yeah, so what did you ultimately decide? Do you have like one nice reason?
Well, for G9, we chose United.
Yeah.
because it's a boiling water and a warm kitchen, so it's not going to cool off.
So it's not gonna be like immediately drying off and then kind of staying on. So yeah, that is a good reason.
And it, since it's just competition.
Right, so it's not gonna ever like actually get down to 0. Yeah. Hi, do you wanna come, maybe you can come move up here? And, maybe somebody gracious would like maybe fill him in or like give a practice explanation to our newcomer. What's your name? I'm Dr. Aramon. So they can kind of give you an idea of what we've been doing and we'll talk about it as a group.
So right now we're just matching graphs with the functions.
You want me to take all that off? Yeah, I'm actually,
Oh yeah, let's just read the function, see which graph is the best possible. What is there?
Did you guys have any questions before we come back? Yeah, no, I know, and some of them are kind of these things where like.
Yeah, but
Yeah, and I think that's the part, there's some that have like a very general shape, where you're like, I know it goes up or I know it goes down, but like they're not, these ones aren't that different. Maybe I'll point out that these ones, they can really try to figure out, struggling which one is which. This one, it actually, actually falls into the order. So like whatever x is 0, this is actually saying y is actually 0. This one is saying, when x is 0, y is very, very small, but not actually 0. So maybe you could think about that, which one. Do you guys have any questions or anything for your practice group?
And it's in the end of the year.
All right, yes.
So his midterms, he wants to show work. You can't show your work. And he's really strict on that.
What was it?
Rules. It was like, he's pretty open. I ended up saying like 4 times. But I'm just looking at it.
Did he give you a time limit? It's great.
No, like right when it finished, there were still the same 9 people left. And he's like, well, we gotta go back to the time if you mind, but I'm gonna let you guys go on a little longer. And everyone's like, I'm like, you just did like 2 pages out of the 7. What do you mean? And
4 hours.
4 hours.
That's great.
It was, we had him over here in SEC. I don't know if you back in like last semester, or last summer.
Oh, you just going so fast.
Yeah. It was like 9 o'clock. There was only me and 3 other people that stayed that long. Everyone else, after one point.
They're just like,
Because he started doing like more stuff in Kelsey one. Like we were going far into rules and all that.
that's great.
All right, so maybe let's chat as a group and we can take turns kind of explaining why we thought a particular graph went with a particular situation. More like, all right, so is there a person that would like to volunteer to go first? About one that you're like, I'm pretty confident this is how it works and here's why. Yes, do it. Okay, what are we doing? Which one?
For E, I'm pretty confident that the equation for E would be G9.
Okay, so you've got E is the cooling kettle problem. The water temperature is, we're saying X is like the time that's elapsed, and Y is the water temperature, and you think it's G9, it's kind of sloping down. So can you tell us why you thought it was this one?
I believe it would be G9 because it's boiling water in a warm kitchen. So before I get any like math part, I just try to think logically, and I'd say that it wouldn't cool off as quickly as you would think. So it would be a dramatic change in the beginning, and then it would never reach one kitchen, so it wouldn't actually hit zero.
So it's never actually gonna touch this axis, and it kind of starts on the y-axis, it starts at a point, because what do you know at time 0?
That is pretty hot.
It's pretty hot, it's boiling, so it's like, 212 degrees Fahrenheit or whatever. Okay, so how do we feel about G9? Do we feel okay that G9 goes with the kettle? Any questions? And it's totally cool, if you guys have questions or you're like, oops, I didn't get that same answer. If you have a reason why you thought about a different one, you can share that too. Do we all feel okay about this one? All right, awesome. So done with kettle. A new volunteer. Yeah, Valerie.
I'll do the F, it's the Ferris wheel.
The Ferris wheel.
And at first, I thought it was, just to go over that, I thought it was G5 because I understood it as like one rotation, because if it was one rotation of the Ferris wheel, then it would go to 0 twice and it would be the 2 times. But then I asked Professor Yarnall and she said it goes multiple times. So because it's going multiple times, then I knew it had to be G11 so that there would be peaks and then lower points, but then all would be equally the same and it has to stay there. So.
Yeah. Yeah, so I don't know if any of you guys have this kind of ambiguous, like some of these are kind of ambiguous, right? It doesn't tell you. And so, maybe some of you arrived at this because you're like just thinking, oh, if it goes around and around, it goes up and down, up and down. But, yeah, I think that was a nice point by Valerie though. Like, oh, if it just goes up and around one time, it would just like go up and then come back down. But this is where, sometimes there is ambiguity in this. Do we feel okay about the Ferris wheel problem? Any questions? All right, a new volunteer. Do you have one?
For cycling, we have G10.
So for the cycling problem, where we're going from one town to another, so can you kind of tell us what you're thinking about for G10?
I think of word problems all the time where they ask if you want to move in one direction to the next.
Yeah.
Like from town A to town B, it's a direct line. So I thought of triangle immediately.
Yeah, okay, so maybe like, can you say, like why does it start up high and then go down low? Or just kind of like you were thinking, I've done these problems before, and this is what always happens.
Yeah, I just wanted to remember it.
Yeah, so I agree with you. This is a super popular thing that shows up where we're saying like, I'm going from point A to point B. And X was the distance of the cyclist from point A, and then Y was the distance from point B, basically, right, town B. And so if we start off like at 0, we're saying we're in town A, so how far are we from town B? Yeah, we're like the whole amount, and then what happens as we get closer to town, like as we go along, we're getting closer and closer to town B, until what happens at the very end when we arrive at town B? How far are we from town B? We're like when we're actually at town B, we are 0 miles from town B. So this is where we're starting off on this axis because we were like some distance from town B, and then our distance from town B got smaller as we got closer to town B. Thoughts, questions, concerns, or like, did anybody have a different way that they thought about this one? Or are we just kind of like, yeah, this is the one that always shows up? And that's okay too. I know like a lot of times, right now you guys have already seen functions a bunch of times, so sometimes this is good. You're just accumulating knowledge that you've used in the past. All right, another volunteer. Yes?
For K, we chose G5.
For K, you chose G5. So the height of the golf shot, you're saying, is this kind of upside down parabola.
Yes, so it reaches a certain height and it starts decreasing from there, and then it reaches, I guess, time lapse.
And at the end, it's like because it stopped at the ground or something. Yeah. What do we think? This one? Do we feel good about it? Yeah. I think that was kind of nice. This is something that shows up a lot, and maybe, actually, Alejandra, I heard you say something about maybe the other golf problem, but maybe like the nice summary of why we see these parabolas is because what's acting on the, like what force is acting on the ball?
Gravity.
Gravity, right? So like, we've seen this a lot in calculus where we've got these like parabolic trajectories because this is exactly gravity acting on the object. another volunteer. Did you have, yeah, Pedro?
For C, I picked G4.
For C, you picked G4. Okay, so this is a movie subscription problem. And I think maybe some people's G4s had dots maybe, and some people's did not. Is this true? Or did everyone have dots? Dots. Okay, do you want to give us an idea of why you picked this one, Pedro?
Because considering how they're charging for a movie, that either charge you for like, well, they're gonna charge you for the movie even if you watch half the movie or more than half.
Okay, so you thought like these dots. I think maybe a couple people didn't have dots. Okay, so did you have any other reasons why you thought like?
The first two movies are free and it starts off right away from the two.
Right, so it's got this x-intercept because we're paying $0 for seeing 2 movies, which is awesome. I would like to hear it from this theater. Any other thoughts or questions about this one? People who had like the line, did you guys feel like, oh, the line's awesome, or like maybe you wanted it to be dots? What do you guys? Sorry? So you like the line because, I don't know, I think maybe because we like continuous functions. But can you say again, Pedro, like why you were thinking like you think the dots kind of encapsulate what's happening?
Because